So for the next 2 hours, we will be having Professor Gautam Makwana, who will be discussing with us the two important use cases of AI. The first one is AI in disease prediction and detection, an area where artificial intelligence is making groundbreaking contributions in improving healthcare and saving lives. The second use case we will be discussing in the next session will focus on AI for waste management in smart cities, a crucial application of technology in ensuring sustainable urban development and smarter living. So please join me in welcoming Professor Gautam Makwana to deliver these insightful sessions. Thank you, sir.
Thank you, Nidhi. So today I will discuss about the use cases on the AI in the disease prediction and the detection. So throughout this journey of the Gyan course, we are focusing on the health scale about how AI can be useful in the health scale. So there are the many use cases. So in this my agenda, I will discuss the various machine learning and the deep learning algorithm, how it can be useful for the medical diagnosis and the comparison of the ML and the DL algorithm in the disease diagnosis process. And I will specifically talk about the lung cancers diagnosis framework that will contain the framework, various algorithm, experimental setup, and the performance metric and the result. Okay. So before going to start my content, I just acknowledge this contributor who are having the giving the very good design of the various medical diagnosis process using the AI. So this is this one. So just recap what is the machine learning. Okay, so this is just framework about the machine learning. Patient record, patient that I already discussed this framework in my previous lecture, and this is the just idea that the machine learning, the data processing is done by the manually, and it will not having the large data set. So at the time when you go for the large data set, this kind of the algorithm, that is the KNN, decision tree and SVM, the performance is very poor in the term of the large data set point of view. And this is these are the in most of the death due to the cancers. Okay, so, every year more than the 10 million of the person are dying because of the various type of the cancer. And so in this case, it is better to, if you detect the disease cancer early, and then we can save the life of the person. That is the main motive of the how we can use the AI in the healthcare system to detect the early disease. So these are the example about the various disease, kidney disease, breast cancer, and the diabetics. And these are the different kind of the methodologies that are having the machine learning, SVM, KNN, and decision tree. And if you just find out that this one, it is having the around the 70 to 90% of the accuracy of the various kind of the disease that we have considered by using the machine learning point of view. And in the same way, there are the different kind of the what is the use of the machine learning algorithm in the cancer diagnosis. So this is your supervised learning, learn from the label data to make the prediction, used for the classifying the tumor and the predicting the survival. If you use the unsupervised learning, then the discover the hidden pattern in the unlabeled data, apply in clustering the patient or the tumor subtypes. Semi-supervised learning algorithm combine the small amount of the labeled data with the large unlabeled data sets useful in the medical images with the limited annotation. Reinforcement learning is used when the learn by the trial and error through the feedback, apply in the treatment policy optimization. Feature engineering, the process of selecting the or transforming the variable to improve the machine learning performance, crucial for the structure electronics health record. SVM, effective in the high dimensional space for classification of the disease. The random forest ensemble of the decision tree, robust against the overfitting, usual for the biomarker prediction and classification, logistic regression, the common baseline model for the binary classification in the survival and decision prediction, K nearest neighbor, instant-based learner used in the similarity based on the drug reposition and the subtype of the classification. So you get the idea what kind of the algorithm, machine algorithm can be used for the what kind of the diagnosis in the cancer. Now, as I already discussed this convolution CNN neural networks, convolution neural network. This path is used for the feature extraction, and this path is used for the training the data sets to give the multi-layer persistent mechanism for your deep learning point of view. So there are this deep learning is used when you have the image at your data set. Okay, in the machine learning, image are less, but the data in the number are the more. So that is the difference here actually. Okay, so whenever we have the image, then it is better to go to the CNN kind of the algorithms. As the same way for the deep learning algorithms, so there are the many deep learning algorithms are used for the different kind of the disease, for the different kind of the purpose to diagnose the breast cancer, to detect the region of the tumor and the comparative study in the breast cancer by using the different methodology of the deep learning algorithm, deep belief network, using the back propagation neural network, different k-mean closing dilation and Kenny edge, and the SMN, CNN and LSTM. It is used for the classification using the heart rate variability and the ECG and comparative study. The skin disease, CNN, and it is a skin cancer also. It is an early detection using the melanoma by using the linear SVM and the CNN. And the heart disease is a to diagnose the disease using the heart sound by using the deep neural networks. Accuracy about the 83%. So there are the different kind of the disease diagnosis by using the different different algorithm of the deep learning point of view. Okay, so this is just idea about the you can get the idea that the how much accuracies even the for this particular case for the disease diagnosis in the cancers. Now, in the same way, the deep neural networks. Okay, so this deep neural networks DNN multi-layer feed-forward network for structural data, widely used in the survival predictions. Okay, CNN specialized for the image data when your data is a CT, MRI, and the histopathologies used to extract the partial hierarchy in the feature. Recurrent neural network is used for the sequential data like the patient record used for the time-dependent health trajectory. And LSTM is a type of the RNN that capture the long range dependency apply in Hull and the time series prognosis. And then the gated recurrent unit efficient RNS variant used in the longitudinal cancer data modeling. Residual networks, that is non-aerial, ResNet. It is the one kind of the deep learning architecture with the skip connection, enable the deep network for the accurate image-based classification, extensively used in the digital pathology. Vision transformer, this method or this algorithm is based on the transformer architecture of the LLM. The transformer-based model adapted for the image analysis, increasingly used for the whole side image classification and the long net. It is also the based on the transformer architecture, variant enabling the processing of the very long sequence greater than the 32 token, suitable for the high resolution pathology slide and multimodal data. There are the different kind of the other deep learning algorithm. UNet, a CNN architecture designed for the biomedical image segmentation, heavily used in the tumor boundary and the organic risk contouring. Affiliate net, it is used for the optimized CNN with the excellent performance at the low computation cost. used in the real-time image analysis and the mobile health app. Graph neural networks, and there is the autoencoder, variant autoencoder, generative adversarial network, and the adversarial autoencoder. So starting from the deep learning concept and starting from the large language model and the generative AIs. Okay, so all are having the some kind of the use cases for the medical sectors. Okay, so they have the different kind of the requirement and the different kind of the accuracy in the term of the outcomes. Okay, so these are the different kind of the how the cancer diagnosis can be done with the help of the different algorithms in the machine learning, deep learning, large language program, and the generative AIs. Okay, so these are the just here. Now I will take the one use cases to detect the lung cancers. The main objective is the early and accurate cancer detection and the lung cancer classification. So there are the three type of the cases in the lung. One is the normal case, one is the benign case, and one is the malignant case. And it is a to get the interpretable, fast, and more reliable lung cancer diagnosis. So this is the main objective of the this case study. And here, the methodology are used to end-to-end concatenate CNN. Concatenate CNN, that is the triple CN by integrating the two distinct CNN model, followed by the multi-rail perceptron, MLP, and the multi-head attention mechanism to enhance the performance, followed by the explainable AI techniques, that is your gradient weighted class activation mapping and the Sapri additive explanation shape. So in this case study, they use the CNN, then they use the mechanism of the MHA, that is the multi-head attention, part of the your large language models. Okay, so it is a combined different algorithms, deep learning algorithm, large language algorithm, and the third is the your explainable AI algorithm to predict the early detection of the lung cancers. Okay, so this is your if you just see the accuracies in the real, the accuracy is around the 90 to 95 or 97, and here they use the explainable AI because the whatever the algorithm previously I just talked, they don't have the any reliability of the predictions, or even the doctor cannot rely on the how the predictions are done. So for this case, it is a to make the early and accurate cancer detection and the interpretability and the fast and more reliable lung cancer diagnosis. So here, so if you, this is your workflow for the lung cancer classification. So these are the input. These are the three different type of the input. One is the normal case, benign, and the malignant input. And this all are the then the whatever the image are, it is the pre-process, and then it is the data speed in the training set. 80% of the images are used in the training set, and testing use the 20% of this one. And here the number of the sample are less in the number, so they use the training image augmentations because the actual images of the around the 110 patients of the different kind of the lung cancer, and then after that they use the training image augmentation, and they use the two CNN models, CNN model 1 and CNN model 2, and both the output are the concatenated. And then after that they use the multi-head attention mechanism to identify the which features or which part of the your image are having the more important in the your classifications. So here it is a multi-head attention mechanism, and then after it is followed by the MLP, multi-rail perceptron, and whatever the output. So that is a classified type of the lung cancers. Type of the lung cancer, one is the normal, second is the benign, and third is the malignant type of the lung cancer. So in the benign and the malignant, so here the cell, in the case of the benign, the cell are not growing. Okay, at the time it is the cell are the cancer cell of the your lungs are not growing very fast, but in the case of the malignant cell of the cancer lung cancer are growing very fast. So here what happened? You know the detection of the lung cancer are at the very last stage. Okay, so if you detect the lung cancer before in the early stage of the cancer, then it is a very it is the doctor can give the treatment in the proper way. Okay, so that is the main objective of the this kind of the AI use in the medical terminologies or medical sectors. Now, whatever the classification, now here what happened, there are many algorithms. They give image classification based on the any algorithms. But here they use the this two explainable AI. One is the grade cam and the shape. So this, what is the use now to get the to interpret the how they classify the lung cancer? If the doctor will know, then there is some kind of the trust. There is some kind of the reliabilities on the prediction of the your lung cancer. So here they do this explainable AI. I will discuss this part in the later part of the my lecture. So this is just give the idea that the doctor can get the idea how, based on what part of the images are given the classify the type of the lung cancers. Okay, so this is one kind of the what you call one kind of the different type of the grade came, and the shape is a two explainable AI. Now in this is your normal image of the lung cancer. This is your benign case of the lung cancer, and this is your malignant case of the lung cancer. And this data set is taken from the National Center for the Cancer Disease IQ-OTA NCDs. Now in this experiment, number of the patient is 110. Image modality is the CT scan. Image format is the diacom, and image resolution is the 512 by 512 pixel per slide. Slice thickness is the 1 mm. Window center is the 50 to 600 HU. Window width is the 350 to 100 HU. And the attributes are used as your tube voltage, 120 kilo peak voltage. Number of the classes is the 3. A normal case, a benign case, and the malignant case. Total number of the images is the 1048. And out of this 1048, benign, malignant, and normal, the 120 images are the benign of the 15 patient, 561 images of the 40 patient for the malignant type of the lung cancer, 467 images of the 55 patient of the normal case about this studies. Now also the patient demographics. So diverse group with the variation in the gender, ages, education, lifestyle, and the geographical location are covered in this study of the early detection of the lung cancers. Okay, now if you just see here, the number of the data set is very less. Okay, 120, 561, and the 467 one. So we want to the deep learning algorithm are running on the large data sets. So we want to augment the augmentation of the data set. Augmentation of the data set. So here the main person, if you just go back to this part, so here this part is the training image augmentations. Okay, to increase the number of the image for the all three type of the lung cancers. So here how we can do the image augmentations. So there are the many way, but here the objective to increase the data set to the 10,000. Earlier it is a 1048. 1048 are the images. Now it is a 10,000 images. Okay. So here the objective to increase the data set to the 10,000 images while maintaining the original class proportional. So all the type of the images are proportionally increased. Okay. By how you do the augmentation? By random rotation to capture the different orientation, width, height, shape to the simulate the varied object position, and shear transformation to distort the image perspective slightly. And then zoom operation to simulate the changes in the object scale, horizontal flipping for mirror image variation, and the interpolation used to fill the missing pixel by the nearby values. For this case, they use the contrast limited adaptive histogram equalization to increase the contrast, and by segmenting the image into discrete area known as the title or block and doing the histogram equalization locally within the each title per block. So before the augmentation, number of the images are the 96,449 and 374. And then after the augmentation, this number will be the 1046, 4,887 and 4,067. So now the size of the images are 10 times, almost 10 times as compared to the original number of the data set. So here, this is the output of the after the your image augmentation. So this is the before the augmentation, and this is the your after the augmentation. For the both the case, normal case, benign case, and the this is for the benign case. This is malignant, and this is for the normal case. So here there is no too much changes in the data sets, but it is giving the more number of the images for the training purpose. And out of this, the 80% are used for the training and 20% are used for the testing. Okay. Now here, you know, this is your CNN model. If you just compare, go back to the, this is your CNN model. Okay, this is your CNN model. They use the feature mapping, pudding, and then it is the first convolution, feature map, and then it is pudding, and the number of the others convolution, the real of the convolutions. Okay, depending upon the this to get the proper feature map that will decide the classification of the lung cancers, whether it is normal, benign, or malignant. Okay. So here what they use here. This is your CNN model 1. Okay, original it is a 224 by 225 convolution, and the size of the filter is a 32. Okay, then after they use the max pudding. This is your yellow one is the max pudding, and other then again it is a convolution of the size is the 1112 by 1112. And the 64 size of the filters. So now size of the filter are increasing to get the particular features in your given image. Which part of the image are useful to identify the type of the cancers. Okay, so this is your case of this one, and then it is the convolution 3, 56 by 56, and the type of the number of the filter is the 128 by 128. 128 filters, and then again it is a max pudding. Again the convolution 4 is used for the 28 by 28 and the 256 size of the filters. And again it is a max pudding, and then it is a global mapping 2D. This is your global mapping 2D. So at the time that this function is the average outing global mapping of all the features from the original image to the last part of your convolutions. At the same way, the CNN model 2. So they use the 2 convolutions here. Okay, this is your first one is the 224 by 225, and the size of the filter is the 16, and the second conversion is a 1112 by 1112, and the size of the filter is a 32. So both the output are concatenate, and then after it is the this yellow part is the concatenated, and then it is a multi-head attentions, multi-head attention mechanism to use. So now here why they use this two CNN model. Okay, so it is a focus on the most discriminative aspect of the input, ultimately contributing to the more accurate and the effective classification outcomes. Okay, the CNN model 1 used to extract the details textual, irregular, module boundary, and the structural abnormalities within the lung tissue for capturing the fine grain variation that are clinically significant. So in the image, there are a very small part, a small part of the image are affecting the lung cancer cell. So that can be possible by using this CNN model 1 and the CNN model 2 use the extract the shape, size, and overall density variation of the lung regions. And whatever the features are expressed by the CNN 1 model and the CNN model 2, all are given to the multi-head attentions to get the attention on your models. Now, yesterday I talked about what is the multi-head attentions. Okay, so here the number of the head is the 4, key is the 16, and the value is the 64. Okay, the main goal of this method is to identify the complex pattern and dependencies in the input data. So in your image, there are the many parts are interconnected to get the type of the lung cancers. The input data are divided into several subspace and the head. Okay, the head is the attentions. So before concatenation, the feature map from the CNN model 1 and the CNN model 2 are individually transformed into the query, key, and the value using the learnable linear projection to capture the different aspects of the feature map, such as a partial relationship and the intensity variations, which are identified region of the interest. Okay, and the MHA mechanism compare a scale dot product attention for each pair of the query and the key vector to calculating the similar between the query and key to determine the importance or weight of each feature in the input data. The resulting now how you get the idea? There is one question here: which features are important and which features are not important. Okay, so here we want to calculate the similar between the query and the keys. Okay, if you find out this weight of each, we want to find out the weight of each feature in your input data, and that can be found out by this multi-head attention mechanism. So here what happened, the resulting attention score are then passed through the softmax function to normalize the value between the 0 and 1. If the value is coming the 0, that feature is the less important, and if the value of the feature is the 1, then it will indicate that it is the most relevant feature for the classifications. Okay, so this kind of the non-radio attention marks to identify which feature are important and which feature are not important. Okay, and the attention marks represent the region or features. Okay, if you just see the image of the lung cancers, which part are important and which part are not important, that we have to identify to make the proper classification of the type of the lung cancers. Okay, so this is done by your multi-head attention mechanism, and then the attention marks represented the region or feature in image that consider the most significant classification. Okay, this can be done by the this multi-head attention mechanism. After generating the attention mark for each head in the MHA mechanism, the output are concatenated. So this is the your just query into key. This is the your use for to find out the similar between the query and the keys. Similar between the query and key, and this will find out the weight of the each features. And then it is connected with the values of the feature, and then you will get the attention values. This value will identify the type of the which feature are important and which feature are not important in the your classification. And after this, the output are concatenated from the CNN model 1 and CNN model 2, and it is a reshape process through subsequent layer to the integrate the refined feature representation. So this is a your what you call it is a large language model architectures MHA, and it is used with the it is used with the your deep learning models. Okay, so this is the techniques of the large language model are used here to classify the type of the lung cancers. Okay, now at the same way, the multi-layer persistome, already I discussed about the multi-layer persistome yesterday. Okay, and the day after yesterday also. So here the output of the multi-head attention layer is given to the global average pudding. Global average pudding, and that is the compute the average value of the each feature across the all positions in the images, effectively correcting the spatial dimension, and global average pudding distill the most salient information from the MHA output, facilitating the compact and the important informative representation. A Bayes normalize used for the normalize the value and to make the training stable. Okay, and the dense layer we know that is the your what you call feed forwarded neural networks. A number of the perceptron and number of the hidden layer are used in the your dense kind of the thing, and they use the Gaussian error linear unit GEDU to use as the activation function for capturing the distant subtle nuance and the intricate relation within the data set. So in the because of this GEDU activation function, it is possible to identify the smallest part of the your image that will affect the your image to identify the type of the lung cancers. Okay, so this is because of the GEDU, because the very small part may be having the cancer, non-cancerous or cancerous cell. Okay, so at the time by looking on the image by the doctor also, that can be possibility that the doctor cannot identify the whether it is the cancerous or non-cancerous cell. So here it can be possible to find out the smallest part of the image can be identified with the help of this activation function, Gaussian error linear unit activation function. Okay, and then after it is there are two kind of the dense plus GEDU and the dense plus GEDU. Then it is the dense plus softmax activation function, and that will use to classify the type of the lung cancers. That will use for the type of the lung cancers. Okay, so this is if you just go, if you just go with the this flow again. Okay, this is the input image, data pre-processing, data speed, and training image augmentation, CNN1, CNN2 concatenation, and then it is the multi-head attention, MLP block, and the saved model. Okay, so this will give the classification of the lung cancers. Now we didn't discuss what is the explainable AI. Okay, so the main objective, because we don't have this topic in our course, so I just give this introduction about what is the explainable AI. The objective is to interpret the model decision making and comprehend which characteristics learned by the model for model classification, provide transparency and reliability of the model, provide the transparency and the reliability of the model. So now, doctor, to identify the reliability and the trustworthy of the model, we want to identify how the decision taken place based on the which part of the image it is classified the type of the lung cancer. If you identify any professional, then it is more reliable because doctors are well experienced and they know what are the part of the image are responsible for the lung cancers. Okay, so this and this will add the trust on the AI-based solutions. That will add the trust on your AI-based solutions. Okay, so this is known as your explainable AI to get the idea which part of the image are responsible for the classification of the image. Okay, so if you identify, then we can get some idea as the professional of the domain can get some plus on the AI based solution. Okay, so this is your explainable AI, and here the reduce the communication between the medical professional and AI technology that resulting the trustworthy, dependable AI based diagnosis and the treatment. Okay. Generally, the cancer specialists will identify based on their experience and their knowledge. Okay, but here, whatever without the explainable AI, whether it is 100% accuracy, but the person will not trust on the decisions. Okay, so for this case, two techniques, namely gradient weighted class activation mapping, that is known as your grade chem, and the second type of the algorithm for the explainable AI is the Shapley additive explanation, employed to provide interpretable insight into the concatenated CNN attention model decision making process. Okay, now this is an idea. The first we will see what is the grade chem. Okay, it's designed to visualize the region of an input image that contribute the most significantly to the model prediction. So here in the benign, which part of the image, which part of the feature are that will identify the type of the cancers. Okay, so I am not a professional, but the doctor can identify which part of the image are having the type of the cancers. So here is designed to visualize the region of the input image that contribute the most significantly to the model predictions. It computes the gradient of a target class with respect to the feature map of the last convolution layer. It computes the gradient of a target class with respect to the feature map of the last convolution layer. This gradient are used to assign importance score to each partial location in the feature map, which are then combined into the heat map. This heat map is superimposed on the input image, highlighting the region that influence the model precisions. So here what happened? Every part of the image are assigned the score, and this score are having the idea about the which features are having the importance, and this is a superimposed on the original image. So here, if you just see the malignant, so here this part of the image is identified to classify the type of the lung cancer that is the malignant. And if you just see even the doctor can also, by looking to this original image, doctor can identify the type of the lung cancer that is a malignant. Okay, at the same way for the benign, so this part of the image, this part of the image is identified as a benign type of the lung cancer, and the doctor can identify by looking to this image. This is your benign type of the image. Okay, and whenever it is a normal case, so here in the normal case, in the grade came, this is your output, and this will identify the normal lung normal patients. Okay, here also the doctor can identify this is the normal patients. Okay, so this will give the more plus on the doctors who are doing the practice on the on the lung cancers. So this will give the more plus on your AI based solutions. Okay. Now, in the same way, another is a SAPRI additive explanation. The SAP is a model agnostic interpretability techniques based on the cooperative game theory. It assigns each input feature as a SAPRI value representing its contribution to the difference between the model actual prediction and the average predictions. This mechanism is used assign each input feature SAPRI value representing its contribution to the difference between the model actual prediction and the average prediction. SAP value provide a reliable measure of the feature importance. SAP assign the individual score to each feature, revealing that impact on the model output. SAP highlight the pixel region that most significantly influence the model output for image classification. SAP said the right on the how input feature influence the model prediction. So this is the idea about this is the input and this is your output of the SAP. So depending upon the value, blue or this red will give the idea about the this value will be blue. So this based on this portion of the image is used to predict the type of the lungs. That is your malignant type. Okay, and this is your red and the blue. So this is the this idea about the which part of the image are used to classify the type of the features, and that kind of the plus will help you by the doctors and the patient also rely on the AI based solutions. And if you detect the cancer in the early stage, it will help the patient also. And also the number of the deaths per year will be the decreased very majorly. Okay, so this is a thus for the sake of the discussion, we will discuss the performance metrics in the term of the accuracy, precision, and recall and the F1. Okay, the accuracy will the ratio of the properly predicted instances to the all insert in the data set. Precision demonstrate the model ability to forecast the positive result. Recall assesses how well a model detects every positive instance, and the F1 score to measure the unequal class distribution. So this is the platform is used either Google Colab, storage space uses 78 GB, backend framework is the Keras with the TensorFlow, programming language is the Python 3.10.1, GPU is the NVIDIA Tesla T4, 15 GB virtual RAM, RAM is a 15 to 15 GB, Visual Studio is the Gradio, operating system is the Windows 10, and these are the library used in this one. And the hyperparameter selection are used the initial running rate, number of the epochs 50, batch size 32, optimizer is a Adam, and number of the attention head is the 4, and the dimension of the key space and section and the section and the 64. So these are the idea about the how you select the what are the platforms that you have to implement when this kind of the use cases you have. Okay. Now, now earlier I told it is the 80% is the training and the 20% in the test. Now out of the 10,000 images, okay, which part of the data set is used as a training and which part of the data set is used as a testing. So they use the k-fold validations. K-fold variation. K is here the 5. So all the data sets are divided into the equal 5 subspace of the data set. So in this fold 1, the 1, 2, 3, 4, and 5. 5 partition of the total data set. 10,000 data, 10,000 images. Okay. So 1, 2, 3, 4, and 5. The first 4 are used as a training, and the 5th one is used as a testing. So that is your fold 1. Fold 2, the second 2, 3, 4, 5 are used as a training, and the testing is used the first one. Okay, so because the data, all the data are having the different variations. Okay, so this way you can use optimize your accuracies. You can improve the accuracy, or you can see the dependency of the data sets can be nullified if there are something unevenness in the data set. Okay, so this is a fold 1, fold 2, fold 3, and fold 4 and fold 5. Okay, so at the time that we have to check the accuracy, precision, recall, and the F1 score. Okay, so if you just say the fold 1 is given the around the 99.83 for the benign, precision is a 99.95, and the 97 recall. F1 score is the 98. So on an average, the accuracy is 99.15, 99.66, 98.82, and 98.92. So this will give the data sets dependency because the data are uneven. 10,000 images, we cannot get the idea which data are the, how we can divide the data set into the training, and the which data set are divided into the testings. Okay, 80 to 25. Okay, 80 and the 28. Suppose if you want to give the 25 and 75, 75 data is the training, and 25 for the training set. So fold. All the sample are divided into the 4 partitions, and then after we have to find out the accuracies. Okay. Now in the same way, there is one also number of the head and number of the query and the number of the values. Okay, so there are the different combination of the number of the multi-head attentions. Okay, 4, 16, and 64, 8, 64, 64, 2, 64, 64, 4, 32, 32, 8, 32, 32, 2, 32, 32. So this is the how we decide the number of the head, number of the query, and the number of the values. Okay, so there are a different kind of the combination for the get the maximum accuracies in the case of the multi-head attention. So here you can say this part 4, 16, and 64 are giving the accuracy, precision, and recall and F1 call in the order of the in the range of the above the 99. And here this 2, 32, 32, it is the given the accuracy, precision, recall, and F1 call in the order of the 80 to 85. Okay, so this will give the how the number of the head, number of the query, and the number of the value can be optimized. Okay, as the same way, I already discussed that there are the many CNN models used for the image classifications. Okay, so here this is your concatenated CNN residual, CNN bottleneck, CNN RES MHA, and CNN BOT MHA. So here all are giving the in the range of the 99s. and this our concatenated CNN MHA given the 99.54, but there is some improvement as compared to the others concatenated CNN with the others kind of the architecture used in the image classifications. Okay. In the same way, the evaluation performance of the model with the different optimizers. So there are the different optimizer, Adams SGD, Adam Max, and RMS Pro. So out of this 4 optimizers, Adam will give the maximum accuracy in the order of the 99.54. In the accuracy is the 99.54, and the precision is the 99.31. Okay, so this is you have to optimize the find out the best optimizer solutions in your models. Okay, we have to select the different possibility of this optimizer. Now, how complex is this model? If you just say the total parameter, weight and bias in your multi-layer perceptrons, okay, then it is the size of the kernel, size of the convolutions, multi-head attention, head, query, and the values all are having the 14.27 millions parameter in this image classification, lung classification, and the model size is the 54.44 MB. The programming size of the programming is the 54.44 MB, and if you run if you take the any image, it will take the 2.23 seconds to predict the single image. Okay, if you just say if you go to the hospital and go for the testing of your cancers, okay, it will take the maybe 1 day or maybe the 2 days or maybe the 1 week. Okay, so this is the advantage here. This model will detect the type of the lung cancer within the 2.23 seconds with the accuracy of the order of the 99s. 3 type only: normal, benign, and the malignant type of this one. Okay, and at the same way, this is just idea. Okay, benign, malignant, and the normal case, accuracy, precision, recall, and the F1 score. And this is the power of the AI. This is the power of the AI. Okay, to use the Chat GPT. Okay, for the different kind of the activity, other than non-criminal activity or maybe the report writings. Okay, so that is not a power of the AI. It is the misuse of the AI. Okay, and if you use the AI in the proper way, then you can get the proper benefit to the society. Okay. This is the idea. What is the confidence matrix? Madam is already told. This is your predicted value, benign, malignant, and the normal, and this is a true value. A normal, benign, and the malignant, and the normal value. This is the ROC curve, and this is the ROS curve, and this is your accuracy curve during the training and the validations. During the training and the validation accuracy. So this blue one is for the validation, and the training is the yellow one is for the training accuracies. Both the accuracies, training accuracy and the validation accuracy. For 5-fold, one data set is during the validations. Okay, so this is just idea about the case here. So this is the idea for the each different value. Okay, this is for the benign. This is for the benign, and this is the value of the benign for the different case. So by it will identify the which part of the image, this image are responsible to identify whether this is a benign type of the lung cancer. So this is marked by the red and the yellow. Okay. At the same way, for the malignant, this part of the image, are the main features that identify the malignant type of the lung cancers. Okay, and this part are identify there is no cancer in the patients. Okay, so this is just idea about the doctor can get the idea, and this is a 100% mapping, 100% matching with the AI output and the output by the doctors. Whatever the prediction by the doctor and prediction by the AI model, both are matching. And then after that, you can say the both it is as a patient, I can plus on the doctor. Also, I can plus on the AI based solution. Also, the trustworthiness will be improved for the patient also, not only for the AI and doctors. Even as a patient, okay, someone told you are having the cancer, then maybe doctors say maybe having the wrong decision. At the time, the AI-based prediction will give the plus that the AI-based solution and the doctor both are giving the same predictions about the type of the patient, type of the cancer for a specific disease. Okay, so this is a improve the trustworthiness of the cancers. Yes. In the this is showing here, madam. Okay, if you just see slide Makwana. Now you can see this is the your 109. Okay, predicted is the malignant. So, there is no only one case are having the negative say. Okay, that can be identified by the confidence matrix. That can be identified by the confidence. So this is a 99 point something. Okay, it is not 100%, but it is a 99 point something. Okay, so if you just say here in the one fold, this fold 5, the precision is the 100%. Okay, so there are the possibility that the 100% is possible, but there is some that's why the data set and the feature are we have to make the more iteration on the your data.
So as they use this K-word validation, so according to that, what will be the general result for accuracy, precision, and quality? Because see, they have used 5-fold, and in each fold they have different result, right? So what will be the overall result?
No, it just depends upon the data set actually. How your data sets are clean, how your data set are pure. If the data sets are not pure, then whatever the fold, you may get the different result in the every fold. Okay, and it is depending upon the convolution type of the algorithm that you use. Now this is the case of the your grade came visualization for the benign, malignant, and the normal case. Okay, so you can get the idea how this two explainable AI. What is the explainable AI here? So that will identify the feature that is useful for the classifier with the high accuracies. Okay, and that can be done with the explainable AIs. Okay, it is not a part of the any what are the architectures and what are the methods to go for the explainable AI, but this is just a case study where we can improve the trustworthy. In my first lecture, I have given the major objectives, okay, reliability and the security and everything. So this is your just kind of the how we put the more reliable on the your AI based solutions. Okay, and this is your just comparison with the state of the art method on the IQ OT8 and WC data set. The training set 950, 833 with a different method. Okay, it is around the 1000 images, and then it is the method of the different method, and this is the your accuracy vary from the 92 to 99. Okay, and this will give the highest 99.54. Okay, you can try with the different kind of the possibilities. Okay, but here it is giving the explainable AI and provide the more trustworthy solutions, AI based solution on the early detection of the lung cancers. Okay, so that is the benign or Barrington type of the lung cancer. So this is the idea here. And you know the cancer is a very harmful. Okay, and if you identify the early detections, that will help for the patient also, and saving the life and saving the cost. Okay, so there are many kind of the advantage here, and the summary is the this use cases greatly improve the early diagnosis and categorization of the lung cancer, a major cause of the cancer-related mortality globally. And use of the gate cam and the sub will that is a visualize that the highlight the region such as the module density, irregularity margin, and opacity area with the lung images that are important for the model decision and making process. The integration is adding of the confidence and the trust in the AI-driven diagnosis with the better accuracy, efficiency, and more precise diagnosis and proper treatment in clinical workflow that help doctor for early detection of the lung cancer in the patient, timely interventions, increasingly survival rate, and improve the patient outcome. The use cases offer the strong performance, interpretability, and user friendliness, make it a viable tool for the lung cancer early detection and classification in the benefit of the patients. Okay, so this is the use cases for the AI disease prediction and the disease detection. So there are the many type of the algorithms, starting from the machine learning to the AI-based deep learning, and then it is the large language model, combination of the deep learning model and the others models with the generative AI, large language model, and the explainable AI. So today, this is the current status of the lung cancer early detections. Okay, so if you want to work further, then you have to work further in these directions. If you use the SVM, KNN model for the cancer detections, that already done the work. Okay, deep neural networks, MLP, okay, already the work is already done. Okay, so we have to focus on the generative AI, the combination of the different kind of the deep neural networks or CNN with the different kind of the architecture used in the generative AI, explainable AI, and the large language models. Okay, so these are the different kind of the, this is your, I think it is a 2025 research paper to get the better accuracies. Okay, so, those who want to work on this region or in this domain, then you focus on the above this level. Then and then only you can provide the trustworthy AI solution of the any domain. Not only that is medical, but the any domain you can put into the your contribution in this AI based solution. Okay, thank you. Five minutes. Phone आया साइड में. हाँ 5 तक. શું કીધું?
લગભગ કારની વાત છે.